ಸ್ಟಾರ್ಟ್
ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಿದ್ದೀನಿ.
ಹ್ಮ್
ಸರಿ.
Good afternoon, everyone. I'm Srivali, and my teammates are Shreyashri, Bhagyalakshmi, and Yashashwini. And today we are here to present PBL on our project called Customer Churn Prediction. And next, going on to the contents: abstract, introduction, background literature, problem statement, objectives, system architecture, presentation of results, performance analysis, application, conclusion, future scope, and references. Next, going on to the abstract. This project predicts that which customer likely to stop using a subscription service. Instead of waiting until customer leave the system and analyzes their behavior such as login, billing history, service usage, and support request. Using machine learning, it identifies customers who are at risk and help companies take action early to retain them. So this improves customer satisfaction and saves money. Next, going on to the introduction. Churn site is a machine learning based web application that predicts customer churn. It also collects data like revenue, engagement, support tickets, and usage patterns. This system uses XGBoost system like algorithm to improve prediction accuracies. It is classified into four risks like local, low risk, medium risk, high risk, and critical risk. So this application is built using the React.js, Node.js, MongoDB, and Flask. It provides real-time prediction dashboards, helping companies identify customers who may leave and improve customers' retention. Next is continued by Yashashwini.
Yes, we can start from the background literature. Here, background literature means studying previous methods and research related to our project. Going through the legacy classifiers, traditional machine learning models like logistic regression were used earlier for prediction. They work well for simple linear data but struggle when customer behavior becomes complex and non-linear. Next, going through the tree ensemble technology, it is advanced models like gradient boosted decision trees combine many decision trees to improve prediction accuracy. These models can handle large and complex data sets better. Next is a accuracy paradox. Sometimes a model shows high accuracy but still fails to identify important cases. Example like if 90% customers stay and 10% leave, predicting everyone has stay gives 90% accuracy, but churn customers are missed. Next one is SMOT. It means a synthetic minority over sampling technique. When data is imbalanced, SMOT creates artificial samples of minority data like churn customers. This helps the model learn better and improves prediction. Next, going through the problem statement. What we say means a problem statement explains the main issue of a project solves, like companies often fails to identify customers who may leave their service. Because of this, companies react only after customers leave. Losing customers increases marketing and acquisition cost. Manual analysis is slow and not accurate for huge data sets. And next, going to the objectives. Here, first one, an automated data pipeline. It means that automatically clean data and handles missing values, normalizes data for better model performance. Next, going through the neutralized skewed data set. It means that churn data sets are usually imbalanced. Use SMOT to balance customer data, like prevent biased predictions. Next, going to the maximize flash capture. Here, it increases the recall. Recall helps identify maximum churn customers correctly. Example like we know like if 100 customers may leave and a model identifies 90, recall is high. Next one is a full stack SaaS implementation. It's deploy the model in a real system and include that and include how and include the real system in this. And next will be continued by Shreya.
System architecture. This explains how the complete workflow of the customer churn prediction, starting from the collecting customer data to generating business insight. First one is data source. This is where all the customers information is collected. The data comes from the database, stores customers records, has personal details, subscription plans, payment history, etc. CSV or percute files, historical customer data sets exported from the company database. API or cloud storage, real-time customer activity, website usage, and mobile app interactions are included here. These are the source provided from the raw these are the sources provide the raw customers data. Next one will be the data preprocessing layer. Raw data usually contains missing values, duplicate records, inconsistent format, and class imbalance. Therefore, preprocessing is necessary. It comes data cleaning. Here it removes missing values, duplicate records, invalid entries, incorrect formats. For example, a customer's age is missing. It is replaced with the average age. Data transforming. Convert raw data into machine readable format. Example, converting male or females into numbers or converting data into numerical values. Uh, Third one will be smart. Here it usually churns data sets are imbalanced. So here it creates the synthesized journal examples to balance the data sets. Next layer will be model layer. This layer performs the actual prediction. Here training pipeline cleans the data used for to train the machine learning models. This project uses ZZ Boost, which is one of the most best classification algorithm. Here it increases the high accuracy, high fast training, handles missing values, and prevents high over fitting. Next it will be interference engine. Here it will predicts and scores the input data. Model registry and artifacts, it trains the data and make sure it uh, predicts the output correctly. Next layer will be deployment and monitoring. The trained model is deployed through an API. Other applications can send customers data and receives prediction instantly. Here business dashboard includes total customers, high risk customers, churn trends, revenue, risk distribution, and it manages the dashboard for decision making. Marketing automation, it is based on the prediction where it sends the discount offers, assign support agents, email retentions campaigns, and also reduce the churns automatically. This is the result of the project where it shows it has 8 customers and at the risk there are 3 customers and the average probability churn and monthly revenue. uh, Here we can also see the customer risk distribution, churn risk trends, and in the second output we can see the average risk score of a customers and who are the customers they are at the risk. Performance analysis. uh, cla- Performance analysis. Here we can see the classification balance, which means it reaches an average tested prediction accuracy score of 89%, where out of 100 customers predictions, 89s are predicted correctly and 11s are predicted incorrectly, which indicates the model performs well overall. ROC and a discriminatory power. Here it scores an area under the receiver operating characteristics of 0.9412, where ROCAUC measures the model's ability to distinguish between customers who will churn and those who will not. Here 0 0.5 is the random guessing, 0.7 is a good, 0.8 is very good, and above the 0.7 is ranged as excellent. Here a score of 0.9412 means the model has excellent discriminative power and reliably separate churners from the non-churners. Target recalling optimization. Recall measures how customers actually churns the customers and models correctly identifies. If 100 customers are actually going to leave, the model correctly detects 83, it misses 17. A high recall is important because missing customers who are about to leave can result in lost revenue. Target precision security. Precision measures how many customers predicts as high risk actually churn. If the model predicts 100 customers will be churn, 76 actually leaves and 24 do not. High precision helps businesses avoid wasting retention resources on customers who are unlikely to churn. Applications will be continued by Bhagya.
These are the applications. The first one is customer success integrations, and this application helps the support team identify the customer who may leave and send the alert so the team can contact the customer earlier. Next, financial health projection. It predicts the future monthly income and helps the business plan their revenue better. And next, product friction auditing, and this application is finds the problem in the product or a service. This helps to improve the futures and reduce the customer loss. And next is the conclusion. The customer churn prediction project, it helps to business identify customer who are likely to leave. It use machine learning to study the customer data and predict the churn before it happens. This allows the companies to take the earlier action and they improve the customer satisfaction and reduce the customer loss. As a result, the business can increase the customer loyalty and improve the revenue and make the better decision. Overall, this project is effective and the useful solution for the improving the customer retention and the business growth. And next, moving on to the future scope. The first one is deep learning time series integration. This use the advanced AI models to study customer behavior over a time. This can improve the prediction accuracy and explainable AI frameworks, and this shows the reason behind each prediction and help user to understand why the customer is at the risky. And next, automated decision testing. This means automatically choose the best offer or action for the customer and help and keep the more customer with the less manual work. Next, continue by Sri.
So next, moving on to the reference part. So Chanty and Giskin to see in the year 2016, XGBoost, a scalable tree boosting system, is been proposed, and it is 22nd ACM International Conference on Knowledge Discovery and Data Mining. Next, going on with the Chawla or NB in the year 2002. Synthetic minority oversampling technique, Journal of Artificial Intelligence Research at 16, 321 to 357. Next, going on with skill learning, that is proposed in the year 2011. Machine learning in Python, Journal of Machine Learning Research 12, 28, 25 to 28, 30. Thank you. This is a presentation of our PBL regarding the topic of customer churn prediction. Thank you so much.
This is the web page of our app project. Here we can see our admin dashboard where we can see customers, predictions, prediction logs, compare settings, and my profile. In the dashboards, we can see a total number of customers we have and who are the customers are that the risk and average churn probability and monthly revenue. Here we can see a risk distribution which is denoted in a pie graph. So customer risk trends, average risk scores of 6 months, and who are the customers are at the risk. And here are the customers who are engaged in this. Here we can see their names, their company, what plan they have chosen, their revenue, what the risk rate is, and what's the churn rate, and then the status and the last active when they are active. And this is the action. Next, going to the prediction, we can see here we have two types of predictions. Here they customers can predict their own, and here we have a quick prediction. Here anyone can predict their plans and get started. The prediction logs involves how many times the customers have predicted their revenue, their churn, and etc. Here we can compare between here we have to select the customers and get to know the predictions of their early one and the later one and what's the rate. This is the settings, and here is the profile. Thank you.